Okay, so we are Team Hefty Protons, and we'd like to give you a tour right now about what we've been working on all weekend. As you can see from our logo right here, where we have a proton that's sitting in a scale here, there are 3 quarks in there. That's actually this typical model that we see of the proton. But if we take those 3 quarks and we go ahead and we mass them as they were to be on this little scale right here, then you would notice that the quarks are actually only 1% of the full mass of the proton. And so we are asking then, where is the other 99% of the mass of the proton? We want to show this to a wide range of people in terms of age and experience, what exactly is happening in the proton. And in order to do that, we're giving a special opportunity to our visitors to the Science Gateway to come inside the proton. And this is what exactly that looks like. So if we were to go through this wall that I just showed right there, it's kind of a chicane. You'd see that there's a series of panels there, and inside, well, in order to get inside, it's a very, very accessible area. It's wide enough that people with mobility issues could actually get through. So there's no restriction on people coming in. And once you're inside, you really get the feel for what exactly is going on inside the proton. And what that is that there are a lot more than those 3 valence quarks. There's all sorts of quarks in there. And they are in these quark-antiquark pairs. They're projected on the walls of the interior of this proton. And every so often, it accelerates. And you see that there's a lot more that's happening because there are a lot more of these quarks that emerge from the C quark field that's behind these quarks here. So our proton accelerates. And also the walls of this proton, they actually also expand. So we get an idea about how the whole shape changes of this contained unit.
So a bit more about when you're actually inside our proton. You walk up into the middle and you see a pillar, and around this pillar are several different stations. We've represented them here as these little hemispheres here, and each station is its own contained interactive unit. So the visitor has their own to focus on, they work through at their own pace. And there's different levels of our interactive storyline for people with different prior knowledge or ages. So there's different paths here. Beginner path is really quick and easy introduction. And if you want to jump up to higher levels or more detail, there's the opportunity to do that as well. And also to go back to the start and go through again if you have a bit more time. And your progress through the storyline is impacted by what you do in the hands-on exhibitions.
So just to start talking about how this hands-on exhibition really brings the quantum world to the real world. So what we have, as Priya mentioned, those central console with those stations for each user to interact with. And on those stations in front of you, you can see an example of what you will have in front of you. So we have our mass balance to the left. We've got our proton on the left, and then on the right-hand side, there is a proton that you can really peer into and see what's going on. So what you can do with this mass balance is you can experiment with the quarks, and then only when you get the right connection and the right combination will you start to see the mass of the proton. And here's an example here with the scientist of how this can be achieved.
Try adding a quark to the scale. Ah, I see you have added an up quark. Nice. Now add a different quark. A down quark. Nice, well done. Add one more and see what happens. Maybe an up quark? So we have these 3 valence quarks on our model of the proton, but the mass still doesn't equal the total proton mass. Let's see what happens when we switch on the gluon field. There we go, we have the total mass of the proton. Well done.
So in our exhibit, the mass of the gluon field will come from an LED attached to the mass balance. And when the user presses that button and lights up the gluon field, that's the final step in the mechanism to getting the proton mass to balance. And then finally, that last part of the exhibit that I briefly mentioned, we've got our proton kind of Russian doll, so to speak. And if the user opens up this proton, they get a closer look of what's going on inside and what the scientist has been talking about. We've got our sphere made of plexiglass in the middle. Attached to the outside are our 3 valence quarks. So we've got our 3 different colored quarks with our gluons in the middle connecting via the strong force. We also have the representation of C quarks will be inside the middle, so our quark and anti-quark pairs. These will be constantly moving, and this can be controlled by the user with the use of that spring. So that sphere in the middle can be moved around and we can see the sea of quarks are moving, or we can also have running through it at the same time, air that's pushing through and blowing the C quarks and moving them in a pattern, just to represent the high speed that the quarks are moving at inside the proton.
So we want to see this for real. And we have a technical report that's ready to go for further development of this exhibition. And we have some next steps. We'd love to get some funding in order to make larger scale prototypes of this, including mock-ups for school students. We want to see about further integration within the Science Gateway structure and with the other exhibits that are going to be there in the quantum worlds area. And it would be very, very nice as well to meet up in real life, after the pandemic is over. It's really been a joy working with this team. We've all very, very much enjoyed it. And we wanted to thank CERN and all the sponsors for this opportunity. We'll take questions right now.
Thank you very much, Team Hefty Protons. I love the prototype. Yes, first, let me invite the judges to maybe give any comments or ask any questions.
Thank you so much for your presentation. I would like to ask a question. Since all of this topic is typically 99.9% quantum mechanics, how much you will spend in organizing it with the classical examples versus introducing before people get to this exhibition an introduction to quantum mechanics?
So in the layout of the Science Gateway, there's a lot of opportunities then for people to get a lot more information about physics in general. So including a walkthrough of the universe, including all sorts of sort of basics about how exactly that's researched at CERN as well. And when you get into this quantum worlds area, this is really where you have enough background that you can get into the subject of what exactly is happening at the quantum mechanical level, and where we can start to get into the strangeness of some of the weirdness that happens in the quantum level.
For example, you mentioned at a certain moment acceleration take place and the shape of your environment changes. Mm-hmm. Would you add something into it? Because all of those effects are highly influenced by the relativity, but are you going to add something into it or just leaving it like that, undefined?
So we actually show inside then the way that there are more quarks that emerge then from the C quark field. And we show as well in this setup here where there are interactives and things like that, where yeah, you can see that there's a change that's occurring basically. Yeah, so we actually can see then that there is an effect when you have increased energy that's coming in via the acceleration of our model proton. We actually also have in the structure too, we've incorporated some things to see, so people can see that the proton is being accelerated, like little alerts and things like that, that sort of hint at the actual accelerator, like the LHC, for example.
Thank you.
You're welcome.
For me, I have a thank you very much for your presentation. It's very nice to see it and to imagine it. I like the idea of the Matryoshka, but as everything for the general public is at this scale fairly abstract, how do you feel people will go and make and relate and understand the difference between what is projected on the wall, what is your little model, and what is your scale model, because you have 3 very different levels. And for the general public, how do you feel they will catch it?
So I think we have implemented this quite well with the selection of the 3 levels you want to go through.
Mm-hmm.
The idea would be that if you say you're on a really basic level, we would try to have like comparisons between or explanations with words that everyone understands. Like they are probably not the most accurate explanations, but everyone knows what a magnet, for example, is. So you could say the gluons or the quarks are sticking together through something like a magnet, or everyone knows a magnet and knows that a magnet is sticking to a fridge. And so we need something similar that keeps, for example, the quarks together. And those are also some really small magnets, but not in real life. And then if you would increase the difficulty, you could have the more advanced, more accurate descriptions. But it was really important for us for the whole project to consider all the different age groups and all the different also knowledge groups. I mean, there are also scientists from all the world coming over to CERN and having a look at this exhibition, also want to see some accurate information. So we try to cover all of this with the 3 different levels of explanation. And then we have also what you saw in the prototype of the video. You always have your personal scientist talking to you. And what he's explaining to you is also depending on your level of knowledge. And in a further implementation of this project, we also thought about machine learning algorithms that the scientist will learn how to respond to certain actions of the person, what he is doing. And if the scientist then realizes that maybe the person is not quick enough, switches to an easier level or to a harder level. But this was not possible to implement over the weekend.
Mm-hmm. Thank you.
Thank you so much, Team Hefty Protons. Remember, you can always give a reaction and a virtual applause if you want. Thank you again.